Hey everybody, we're going to keep talking about percents today, but specifically we're going to talk about the percent of change. Now, we're going to look at the definitions. When you're taking notes, I would never copy down every single word of this definition because I might not need it all. I'm going to copy it down as much as I need to and maybe write it in my own words so that I remember what the definitions are. So, our definition says a percent of change indicates how much a quantity increases or decreases with respect to the original amount. If the new amount is greater than the original amount, it's called a percent of increase, right? Because it's getting bigger. If it's less, we call it a percent of decrease, okay? So when you're putting this in your notes, make sure you're using your own words and you're putting it in a way that you can really understand it. To calculate the percent of change, we can write it as a fraction and use our proportion strategy, right? The percent of change is the ratio of the amount of increase or decrease to the original amount. And this ratio is equal to the percent of change over 100. Now, it tells you here how to find the amount of increase or the amount of decrease. I always like to do them the same way. So if I'm looking for the change, right, the amount of increase or decrease, what I always do is take the new amount and subtract the original amount, right? If I started with $15 and now I have $20, I would do 20 minus 15 and get 5. The change is 5. It's an increase of 5. Now if I started with $15 and now have $10, I would do 10 minus 15 and I would get negative 5, right? If I started with 15 but now I have 10, it was a decrease of 5. That's where the negative sign comes in. All right, let's take a look at a couple examples. Now remember, when we're solving percent problems, we can always use the proportion method or we can use the percent equation. Even with percent of change problems, these are still percent problems, we still use the same two basic things, okay? So our example here tells us to identify the percent of change as an increase or decrease. So I'm looking at my original and my new right now. If whatever amount I'm talking about started at 140 and it went up to 189, that is an increase, right? An increase. So I'm going to want to find what the change was because I'm looking what percent is the change from the original. So my change is going to be equal to 189, that's the new amount, minus 140, that's the original amount. So my change equals 49, right? An increase of 49. So now I could set this up two ways. I could set up a proportion, 49 over the original amount, 140, equals P over 100, right? We have that proportion there. We could also write this as a percent equation, right? 49 is the change, that's the part. Could write it as 49 equals P times 140, or I could write that as 140p, right? 49 equals 140p because 140, since that's the original, that's the base. Now, I'm going to use my proportion method to solve this problem because when I'm looking for the percent, I like to use the proportion method. So I can do 49 divided by 140. That gives me 0.35 equals P over 100. And now I can multiply both sides by 100 to get rid of that denominator. And 0.35 times 100 is 35 equals P. So my answer is 35%. That was the percent increase. Positive 35% was the percent change, okay? Example B, we can do the same thing, except here I notice that I'm actually going down in my amount. I start with 70, I wind up with 59.5. That is a decrease, so we'll note that at the beginning. We're going down. Now, to find the change, we can do 59.5 minus 70. So that's going to tell us how much it changes by. So 59.5 minus 70, that's going to give me negative 10.5, right? And that negative is an indicator that this is, in fact, a decrease. Now, I'm going to set up my proportion. I'm going to use a proportion to solve this one again. Negative 10.5 over 70, which was the original amount, equals P over 100. So I'm going to simplify that negative 10.5 over 70. When I divide that, I get 0.15, and that's negative, equals P over 100. And when I multiply by 100 on both sides, we cancel there, and we get P equals negative 15. So the percent of change here was negative 15%, or a decrease of 15%. Now, there's a couple of different ways that percent problems can look, right? We could find the percent of change, but sometimes we're going to know the percent of change. This happens a lot when we're shopping, dealing with money, investing, and we want to look for what a new amount is if we know the percent of change, right? If there's a percent increase, what is the new amount going to be? It's going to be bigger. If there's a percent decrease, we know it's going to be smaller. Now, we know that the original amount, right, is always 100% of itself. So if we're looking for what a new amount is after a percent increase, what we do is we add the percentage to 100%, and that's going to help us calculate the new amount. If it's a percent decrease, we subtract the percentage from 100, and we use that to calculate the new amount using either our proportion or our percent equation. Okay? For these problems, I like to use the percent equation because we know the percent and we're looking for what the part is or the new amount. So let's take a look at this example. If we're shopping, we want to find the sale price of the pair of jeans described in the table. We know that the original price is $48, right? That's the base. So we know that the base is 48. We're looking for the new amount, and we need to use the percentage, the appropriate percentage, to calculate what that new amount is going to be. So if right now we're looking at a discount, that's going to be a percent decrease, so we need to use 100% minus 40%, right? If we're saving 40% off of 100%, that means we're going to end up paying 60% of the original price. So that's what we're going to use in our equation. Now, instead of 60, remember, if it's the percent equation, I'm going to write that as a decimal. 0.60, or just 0.6 would also work. And we're going to do 0.60 times 48. And 0.60 times 48 gives us 28.8. So A equals 28.8. So that means the new price of those jeans are going to be $28.80, right? Let's try one last example with a percent increase, right? We're still going to use the percent equation here because we know the percent, so this will let us do the problem in fewer steps than if we use the proportion. So we want to look for the new value. Remember, that's A. That's the part. And we know our base, what the stock started at, is $7.20. We'll write 7.2. And we know our value is increasing by 8%. So if our value is increasing by 8%, that means we take 100% of what the stock started with, and we're going to add 8% to that. So our new value is going to be 108% of the original amount. So if we're going to write that as a decimal, we write 1.08. And when we calculate 1.08 times 7.2, we get 7.776. So that's our new value. But since we're working with numbers, we're going to round that to the nearest cent, and we're going to get $7.78 is the new value of the stock, right? It started at $7.20, and it is now $7.78, an 8% increase. All right, that's our last example for today. I will see you guys in class tomorrow.